Hello and welcome to a beautiful golden hour in Kansas. As you can see the light coming through my window. Today I'm going to be talking about cognitive development, which is founded by Jean Piaget. Please bear with me, my mouse battery died, and so now I have to use the touchpad on my laptop. So thank you for your patience. So let's start with some of the basic beliefs of Jean Piaget. So his work is founded on a biological brain development standpoint. So it's age based developmental milestones that are structured into unique, um, distinct universal stages. So basically, he's taking out the social and the culture development pieces and just talking about what's happening in the child's brain. So this also means that children learn through interactions with their environment. So no adult or parent is necessary for children to learn in their environment. And they are solitary learners or lone scientists. I love that term. Children learn best through independent exploration and discovery, is what he believed. So he also believes that cognitive development is what stimulates language development. And some of his works include the 7 conversion tasks, which help us understand what's happening at each of the 4 distinctive stages in child development and human development in the cognitive brain. So these 7 are number, length, liquid, mass and matter, area, weight, and volume. Volume would be water displacement. And all of these are mastered around the age 9 to 11 because they're starting to learn in science class about volume, which is the most difficult one to grasp because they learn that water may take different forms, but it still holds the same volume. So, one of the arguably most famous and actually my favorite works that Piaget did was his liquid water conversion tasks. And so, this is mastery of understanding that volume doesn't change, though shape might change. So, part of this might be for the children who are under 7 years old. They think that because something is taller, that means that there's more. And so all of his 7 conversion tasks are overlapping, but this one is where you can really see children begin to understand and mold their brains to consider different ways of thinking that aren't as concrete. Okay, so now I'm going to invite you to get 2 glasses of water that are filled to the same height. Now, you can start with glasses like you see on the screen where they're shorter and then you put it into a thinner, taller one. But because I'm limited on glasses, I'm going to use a larger glass and a smaller glass. So essentially, you ask the child, which of these has more? Is it the same? Or is it the same, more, less, or equal? And then the child will say, well, they look the same. Now, while they're watching you, you take the water and you pour it into the glass. And now you say, is there more, less, or the same? Which one has more? And the child is generally going to choose the one that is taller, unless they understand the concept of volume. And volume means that even though the water changed forms and is now shorter in this glass, it is the exact same amount of water as we began with. And then researchers even go as far as to take the water that was in the big jar and pour it back into the small jar. And children are able to see that it's the same amount. So even though the child does not understand the concept, um, if the child does not understand the concept of volume, they will still think that this is the same amount, even though it was poured out of this glass. So they don't understand that although things can change shape, they don't change volume. And keep thinking about this because we're going to come back to it with every single one of our stages. Along with the 4 main stages, there are 4 main concepts in Piaget's cognitive development theory. So we have schemas, which are categories of knowledge that help us to interpret and understand the world around us. So often as children are growing, we're learning, they have to change their schemas about understanding what something is. For example, water can change form, not just because it's shorter, there's less. The next one is assimilation. So taking new information and categorizing it into already existing schemas. So assimilation would be understanding that this amount of water is the same as this amount of water, even though they look different. Accommodation is the ability to change existing schemas in light of new information. The only way to create a new schema. So changing their schema to understand that this is the same as this is the same as this. And then I can never say this word. Equilibration, changing behavior and to account for new knowledge. So, saying that a child learns that if they fall off monkey bars, they could hurt their arm. So, they're going to be more careful when they're on the monkey bars to not fall off and hurt their arms. Another category of assimilation could be a child understanding that water can be different colors. So in Kansas City, we are the city of fountains, and often we'll change the color of the fountains for holidays. So if the Chiefs are winning, it's red, which I think is a terrible idea to turn the water red. It just looks terrifying. But my favorite one is St. Patrick's Day. We turn them green. So understanding that even though that water is green, it's still water. And they're able to categorize that, okay, you can dye water and it's still water. The first stage of Piaget's cognitive development theory is sensory-motor stage. And this is from birth to 2 years old. And this is how they understand the world around them through movements and sensations. Sensory. Get it? Sensory? Your senses. So developmental change, they understand they're separate beings from individuals and things around them. They start to understand object permanence. So even though this cup is here and now they can't see it, it's still there. We also have action equals reaction. So if I want this water, it could splash. I don't want to do that right now though, because it would get all over me. And then they use basic actions to understand their world. So let's say, obviously they wouldn't have scissors, but they can understand that this is a hard surface because I'm hitting it and it makes noise. This must not be as hard because I'm hitting it and it's not making as much noise. I can also sprinkle this and understand that it makes noise when I touch it. So really just basic, very basic. And then I like to talk about toys in these stages because that's something that child life uses quite often. And I have always struggled with using cognitive development theory to choose toys. So toys that engage their senses from ages birth to 1, and you want bright colors, noise making, textures, so all of the things that can engage their eyes, their ears. Maybe you include some taste. You want things that feel different, so maybe introducing them to these mini ears that are kind of scratchy, and then also feeling this, how they're smooth. And then from ages 1 to 2, they're doing a lot of cause and effect. So water tables, stuff like that are some of my favorites because they also engage their senses, and exposure to language. So like reading them children's books, but they might not sit still. So you'll want to also include some of that sensory activation. So maybe a book that has a little character that you put your finger in, or it's a touch and feel book. And then puzzles, very simple puzzles. Some other activities that you could include are hammering sets where the kids get to hit things through, nesting cups where they can fit into each other, push and pull toys that make noise. Those are always very exciting. Play vehicles that you can put little plastic people in and take them out of. Lots of just exploring and feeling new things. And then as they get older, you can introduce them to dolls and stuffed animals, and maybe a little bit of musical instruments. That also gives them a sense of cause and effect, and construction toys that can snap. Okay, so now let's talk about the liquid experiment and why, what a child between the age of 0 to 2 would think about it. So what a child is doing in the sensory motor stage is understanding how water feels, how it smells, how it tastes, and what it does when you hit it, when you dump it, when you splash it. So they're really exploring all of the things that you can do with water. And I included this adorable picture of baby Bowen, who I have been watching. And I think it's a great picture because what is he doing with his toy keys? He's putting them in his mouth. This toy is great because it offers a bunch of different textures on the keychain. It also makes noise when you press the buttons, and it's safe for him to put in his mouth. Ages 2 to 7 is the pre-operational stage, and this is a pretty big area to have for a concrete stage. So obviously, children who are 2 are going to have different interests than a child who is 7. But according to Piaget, the pre-operational stage falls across all of those ages, and they're learning through pretend play, imagination, magical thinking, and describing experiences through play. And they're very egocentric. So they're not like egotistical where they're like, oh, it's all about me. But because of their age, they can't really think about what others are truly feeling and understanding that like their feelings are different from my feelings. And so their developmental changes, they think in concrete terms. They develop symbolic thought. So basically, this means that I can pick up this hand sanitizer and pretend it's a cell phone, right? So they're being symbolic between these two things. Um, and they struggle with logic, excuse me, and seeing others' points of views, as I mentioned before. So children do a lot of imitating. So they mimic other people and other people's actions, their words, even if the individual they are modeling is no longer in front of them. So they're using their memory to be like, oh, well, my mom talked about buying groceries when she was on the cell phone. So I'm going to use this hand sanitizer and talk on the cell phone to my mom's friend who was talking about groceries, right? So symbolic play, children begin assigning characteristics or symbols to objects. Um, they can project the properties of one of the objects to another. So this hand sanitizer becomes a cell phone and can talk to people. Um, they enjoy playing with puzzles, snapping construction toys. Again, really just like things that you can do and push together, and then there is a reaction, and they learn that, oh, this happens. We can do basic craft kits, varieties of blocks. So what I mean by that is like having blocks that are different shapes, like triangles, squares. Some of them are bigger, some of them are smaller. They can learn how to fit those together. Learning games, these can be on the computer. They could also be like really simple board games as well. They enjoy playing house, playing with dolls, slime, and they begin picking up some sports. So at this age, they're really just exploring the world of play that we really think of as adults for children. Another thing that is really important, children at this age begin to draw, and their drawings may not be accurate, and often they do tadpole drawings where the head is like gigantic and the body is really small, because in their eyes the head is the most important part because it's the person's face. And they'll actually assign the size of the person to the importance they have. So maybe I would draw myself bigger, I would draw my brother smaller because I didn't like my brother. I actually like my brother. This is just an example. And then my parents would either be, they'd probably be around the size of me. It's whoever I think is most important in the picture will be the biggest. Also, because of their learning through pretend play and really observing and mimicking, they're going to ask a lot about what things are called. And if you've ever been around a child who's between the age of 2 and 7, they will often be like, what's that? Well, what's that? What's that? Why? What's that? So they really just want to understand what it is that they're seeing in the world around them. So now let's look at the pre-operational stage in terms of the liquid experiment. So we're in the pre-operational stage, of course, and they're thinking in really concrete terms. So they'll be like, that is water. Water is wet. Water does this, water does that. So they can verbally describe water. They know the uses. So like, I take a bath, I drink it, I cook with it, I swim in it, I water my plants, etc. And then they associate water with experiences and places. Now, in this picture, I have my cousin Willow, and she is adorable. We hung out, we went to the park. I chose this picture because this girl was having the time of her life. She's in her Cinderella dress with her swim goggles on. She actually had them on her face earlier in that day with her sugary pink cowgirl boots. We went to the park, and something that was amazing that happened. She's 3 years old. She started looking at the horse and the duck that you can ride on. I don't know what they're called. And she was like, it's okay. I'm your friend. We'll be your friend. See, you have a friend over there. So she was assigning feelings to these inanimate objects and interacting with them like they were real. We also were pretending that the playground was underwater and we had to swim everywhere. And it was super exciting. But this age is really, really imaginative, but also very concrete in terms of how they think of things. That leads us to the concrete operational stage, which is age 7 to 11. So this is when children start to really enter grade school. Characteristics, they begin to think logically and understand conversion. They still have very rigid thinking, and they begin to develop empathy. So this means that if Sally isn't at school that day and she's sick, I can realize, oh my goodness, I've been sick before. That must really, really stink. I hope that she's doing okay. In terms of developmental change, we have logic and organized thinking. Still concrete thinking. They use inductive logic and thinking. They differentiate themselves from others. So really understanding that they have their life and I have my life and we are different. Something else that is really important is that they understand the idea of conversion and reversibility. So if I do something, I can undo it and it'll be the same as it was before. Along with the concrete operational stage, they understand classification. So this means that children can classify objects into groups and subgroups. For example, we can sort things by colors, warm colors, cool colors, green, red, blue. We can also sort them by size. We can sort them by food group, kind of thing like that. And this also brings in the concept of seriation, which means that they group objects based on weight height, and importance. So kind of like I talked before about children drawing tadpole people where they think that the head is the most important, that's kind of an idea of um, seriation, and also drawing like more important people larger. So for toys for ages 7, we have slime, tablets, remote control toys like remote control cars, remote control planes, sports, strategy games, stuff like that. And then 8 and up, we have elaborate crafts and science kits, more complex sports, and more complex board games. So though I have like 7 and 8 separated, I just wanted to include some of the younger stuff that might not apply for 8 and up, but they all kind of go together. So at this age, we're really looking at Legos, Magnetiles, games that require strategy like chess, checkers, or Jenga. We also have tablet and computer games, also like Nintendo Switch, PlayStation, Xbox games. A lot of more complex things to help their brains really develop and mold. Here we are back to water conversion. So they have very logical thinking. And on the left, you'll see two little girls. I watched the little one, and the older one decided that she was going to go and pick up trash, and she was the neighbor. But it was interesting to see their thought process because the older girl knew that though we were picking up trash, it would come back. And the younger one was like, oh, we're done. We never have to do this again. So she was confused when the older girl asked her if she wanted to pick up trash because she was like, well, we already did that. So why do we have to do it again? So that's an idea of conversion and reversibility, and understanding that though something might happen, things change. So, in terms of concrete operational stage and the water conversion task, they understand that different containers look different, but still have the same amount of water when they see you pour it. And they understand that water can take on different forms, even if it doesn't look the same. So, like I was saying, colors of water, are there bubbles in it, stuff like that. And at this age, they might ask like, why is water blue? You know, so like if they see that the water is green, for St. Patrick's Day, younger kids would probably be like, oh, okay. But at this age, they're really like, but why is it green when it's usually blue? Now we're at formal operational. This is the final stage of Piaget's cognitive development stages. So this is age 11 and up. So all the way through adulthood, through late adulthood, through aging. So in his eyes, you have reached the top of cognitive development by the age of 11, basically. So this is when you begin considering moral, philosophical, ethical, social, and political concepts. I know, crazy, right? So the developmental change, they have abstract and hypothetical thinking. So like, if I were to pour this water into here, would it still be the same if I dumped some out? So this would obviously be the younger age. But like, if I were to pour this into here, would it spill? And then they'd be like, well, yes, it would spill because there's not enough room for the volume of this water. Um, We also have deductive logic, which was what I just did, where it was like, yes, it would spill because there's not enough volume. Reasoning from a general principle to specific information. Sorry. So going from a principle of is water wet to understanding like what really it means when water is wet, kind of thing. So there's more sophisticated rules of logic. They then use these rules to understand how abstract concepts work to solve problems. Children can analyze their environment and make deductions. They can create theories about what is possible and what might happen in the future based on their existing knowledge. So this is known as hypothetical deductive thinking, which is pretty cool. So some toys and activities for this age would be sports, things that offer self-expression like art and music, individualized hobbies, so they really begin to choose their own adventure with what they want to do, bracelet making, tie-dye, video games, things that they can really pick up and make their own. So here we are with the formal operational stage, and this is where we have deductive thinking. So in this picture, you see the boy wondering, is this water cup half full or is it half empty? So it's really a hypothetical, asking things that aren't exactly there. So an example of this is like, what things can we do with water? Is water wet? Studying water through mathematics. If I do X, will it change Y? They do a lot of problem solving of what if and think of numerous ways to solve the problem and then act. So I chose this picture on your left side of the screen because I think it's a great use of deductive logic and deductive reasoning. So in this picture, we have my fiance Peter on the right, and then his two roommates. Jack is the one stuck in the playground, and Palmer is the one who is trying to help Jack out of the situation. So basically, Jack was like, I wonder if I can fit through these ropes on the playground and get through it. And I don't think he used a lot of deductive reasoning there because he didn't consider how his shoulders are larger than his waist and his hips. So then Peter and Palmer looked at him and tried to decide the best course of action. Once Palmer picked up Jack, Jack was able to wiggle his arms out of the rope and get out. If Jack had been by himself, it would have been a lot more painful, and he might not have gotten out too quick because his arms were stuck like this, so he had no power to push down and get back up. So I just really like that picture because I think it's a great use of using deductive reasoning and not using deductive reasoning. Because just because our developmental state is there does not mean that we're going to capitalize on it. And then our final wrap up. In this picture, I have Jules, the little girl, and her brother Bowen, who I showed earlier. And this is of Jules helping Bowen play. And often I see her mimicking what her mom does. When he's crying, she'll grab one of those toys and wiggle it back and forth. So she's really imitating what her mom is doing because she is at the pre-operational stage. So what do you think are some of the strengths of this theory? What do you think are some of the weaknesses? I kind of talked a little bit about that. And how can we apply this theory to our interactions with children every day to help them learn and understand the world around them a little bit more and really boost their development? So I hope that you really enjoyed this. And here are my references. And I hope you have a great rest of your day. And thank you for bearing with me with my touchpad problems. Bye.